Today's notes are again brought to you by the world-famous San Diego Zoo, and our note titles are 12-4, Angle Measures, and Segment Lengths. Again, it doesn't really look like it, but this is half of the page. We're going to take half of our notes on angle measures with 2 examples, and then half of our notes on segment lengths with 2 examples. And a reminder that you need 2 markers for these notes. On the top half of your notes on the left-hand side, I'd like you to make a box and write this question. How do you find an angle measure if the vertex is inside the circle, but not on the center, or outside the circle? Now this is kind of new to us. We know how to find the measure of an angle if it's a central angle, that's if it ends on the center, or if its vertex is somewhere on this yellow line, but we don't know how to find an angle measure if it looks like this. Now, if I asked you for, let's say I called this angle 1, you could tell me what it is easily if you knew this angle because these are vertical angles. But what if all that I gave you was this arc measure here, which I'm going to call x degrees, and this arc measure over here, which I'm going to call y degrees? Could you find angle 1? The answer is yes, and here's how. The measure of angle 1 is actually equal to the sum of both arcs divided by 2. So basically it's the average of those 2 arcs. Now what if you wanted to find, let's call this angle 2? How would you find that one? Well, this one's a little trickier. But again, what if I gave you this arc measure, which I'll call x degrees, and this other arc measure, which I'll call y degrees? Now this one's kind of important, the order. The measure of angle 2 is equal to x degrees minus y degrees divided by 2, with a special note that this is the bigger arc. And that's how you would find either angle 1 or angle 2. Now let's put this information to use. So side by side, I'd like you to create example 1 and example 2, and here's some red river hogs in the middle. Let's take a second to draw the circle with this angle and these 2 arcs, and this circle with these 2 chords and these 3 measurements. Now when I start example 1, the first thing I notice is that the vertex is on the outside of the circle. That tells me that the measure of the angle, so the measure of the angle, is equal to the 2 arcs being subtracted divided by 2. So let's go ahead and see what those measures are. The angle is 70 degrees. Remember, the bigger angle, the bigger arc goes here, so that would be x degrees minus the smaller arc, that's 110 degrees, that's going here, and then divided by 2. So now I'm going to have to do some calculations to find that measurement. I'm going to go ahead and multiply by 2 on both sides. I get 140 degrees equals, and 2 divided by 2 is 1, so I have x minus 110. So if I add 110 to both sides, I can isolate my x to find that it is 250 degrees. That means now for example 2, they've given me a circle, and they've given me 2 lines like this, and I notice that there's an angle they've given me that's inside the circle, but it's not on the center. That means that I know this relationship. In this case, the angle is the 2 arcs added together divided by 2. So let's see what we have here. My angle is 35 degrees, and my 2 arcs are 30 degrees and x degrees. Now when we're adding, the order doesn't matter, so I'm going to go ahead and put 30 degrees in x. If you chose to put the x here and the 30 here, it would not change your answer. And divide by 2. Now I'm going to do some calculations to isolate my x. I'm going to multiply by 2 on both sides to get 70 degrees equals 30 plus x. Now I'm going to subtract 30 from both sides to get that arc right there is 40 degrees. Now for the second half of our notes. I'd like you to create a box and write this question. How do you find the length of a segment in a circle if those segments do not ever go through the center point? And this is an important point, that they don't go through the center point. Now it all kind of depends on how those segments look. For example, the relationship is different for if you have a circle and you have two chords that create angles that are inside the circle. It's different in a circle if you have segments that create an angle that's outside of the circle, or even different, what if you have a circle where the segments are created by a line and this being a tangent line? So let's go ahead and write down what those relationships are. So for scenario 1, I'm going to go ahead and label this section as A, B, and C, and D. The relationship in scenario 1 is that A times B is equal to C times D. I want you to know that this is a piece, and a piece of one whole chord is equal to a piece times a piece of one whole chord. For the second one, I want you to think of this as like the outside part, and then this section right here being the whole. Well, that's a secant. And then for this one, we'll call this the outside part. And then from here to here, this is the whole. Now, the relationship here goes something like this. The whole times the part is equal to the whole times the part. And now for the last one. For this last question, I want you to remember that this is a tangent and this is a secant. So I'm going to go ahead and call this the tangent length. And then for this one, I'm going to call this the part. And this whole part right here put together as the whole. Okay, the relationship for this one is that the tangent squared is equal to the whole times the part. I'm sorry, mine doesn't fit in there. I hope you can squeeze that in. So these are the three relationships. So depending on what you see inside of your circle, you're going to use one of these three relationships. Now I'd like you to take a moment to copy down example 3 and example 4 and these two diagrams. And for both, I'd like you to add these directions. Find Y and find M. Now for these two questions, they're asking us to find a length, not an angle measure, which makes me think I'm going to need to use these examples right here. So I'm going to look at these scenarios and ask myself, which of these scenarios is most similar to this one here? The first thing I notice is I have two secant lines that are going outside, creating an angle on the outside of the circle, and I have two scenarios that do that. But scenario 3 has a tangent, and neither of these lines is a tangent line, so it must be scenario 2. Scenario 2 says the relationship is the whole times the part is equal to the whole times the part. So let's go ahead and identify these. I'm going to call this line the pink line, and this one the orange. Okay, so let's start with this one. The whole of this line is 8 plus 6, so that's 14 times the part is just this section on the outside of the circle, which is 6, equals the whole, which is y plus 7, times the outside part, which is 7. Now I'm just going to solve. So first let's do these calculations. What is 14 times 6? Well, that's 24. 6 times 1 is 6 plus 2 is 8. So I have 84 equals, and now let's distribute this 7y plus 49. I'm going to subtract 49 from both sides to isolate my variable. 7y equals, let's see, borrow. So I have a 7 and a 14 now. That's a 5 and a 3. So y equals 5 yards. All right. Now let's look at our second example. In this circle, I have two chords that intersect in the center, and only one of our scenarios does that. The relationship it says here is A times B equals C times D. These are pieces of the chords multiplied together. So I'm going to say this is my A and this is my B. So M times 6 equals, this could be my C and this could be my D, 3 times 7. Now it's just a matter of solving. So 6M equals 21. If I divide by 6 on both sides, M is 21 over 6. I'm going to go ahead and see what that is. 6 goes into 21 3 times with 18. It doesn't quite make it. It has a remainder of 3. Bring down my 0. And 6 goes into 35 times. Subtract, and I get M equals 3.5 inches. And that's how you find a length.